All right, welcome everybody to today's seminar. So I'm going to do the introduction today, so it'll be a little bit different because we're actually having Mary Collins be the speaker, which is really great. It's nice. And so just to introduce Mary, for those of you like me who maybe haven't seen her speak in the past, she has a bachelor's in sociology from the University of Wisconsin-Madison and an MA in applied sociology from Central Florida. And then she did her PhD in environmental science and management from at the University of California, Santa Barbara. And then she decided it was too warm in Florida and Santa Barbara. So she did a postdoc at the University of Maryland, and then she joined the faculty actually at SUNY ESF in 2015. She became an associate professor there in 2021. And then in 2022, we won her over and she joined our faculty here. And we're excited to have her give a talk just because, you know, many of us haven't had the chance to meet with her before or to see her talk about her research and to talk a little bit about what she does. She is an environmental health scholar, so she investigates the interplay between socio-environmental factors and public policy to promote justice and sustainability. And very cool, she actually led the Center of Environmental Medicine and Informatics at SUNY ESF, which was established through a 2019 SUNY Discovery Challenge Award. So yeah, we're really excited that Mary joined our faculty, and I'm really excited to hear more about your research.
Thank you. Thank you so much. Thanks. Great. Well, it's a super pleasure to be here. In some ways, I think that it's almost like a little more nerve-wracking to talk to all the people you know than all the people you don't know sometimes. So, but it's an indication of just how excited I am to be here, and thanks for having me today. So, when I was putting together this talk, I was reading the title thinking like, who made this really long title? The title of the talk is Balancing Industry, Environment, and Employment, and I'm going to show you a policy simulation paper that I wrote at the beginning of the year. And but if I have to give you just a little bit more of nuts and bolts description of what I'm going to talk about, I'm really interested in introducing myself to SoMAS, and I'm going to do that by talking about what excites me the most. I have 3 papers that I'm going to talk about today. They're wildly different, so I'm going to, try and do the gymnastics that it takes to connect them all. And then, I really want to highlight the collaborative activities that I do with the hopes that somebody will reach out to me and be interested in talking further about my work and how our work might be connected. So all the work that I do is really connected to what I see in the quote unquote real world. Obviously, I'm interested in contributing to the scholarly literature, but all of it's really connected to the generation of actionable science, the connection to people, places, and decisions. So my worldview, and I see lots of students in the room, so this is probably not earth-shattering to you since I've talked about it a lot, but I really view all of the settings in which I do my research as a socio-environmental system. And to me, that means that it's a tightly linked social and biophysical substance system, and you really can't study one without thinking about the other. Obviously, we isolate parts of the system to do different research projects, and we scope our projects appropriately, of course, but making sure that you remember, right, that like the work that you do in a natural environment or in a biophysical environment is inexorably tied to decisions that go on outside of that system and vice versa. So, I think that when you work in a SE system, you are maximizing the likelihood of generating some science that's usable for people who want to make decisions or for environments that you might want to protect. So today, as I mentioned, I'm going to talk about three different sort of streams of research that I've been working on. The vast majority of what I'm going to talk about today is the first one, which is environmental inequality and justice. But I'm also going to talk about the sort of larger collaborative projects that I've been working on. One is wastewater epidemiology in New York State, and the other is translational environmental health. And I'll get to exactly what those things are. But really, I came at this topic because I spent formative time as a student working in the Everglades and watching the sort of restoration and protection go on in that part of the world. And then, you know, neighboring communities were dealing with industrial pollution, and there was so much activism going on to protect the Everglades. And you would listen to the communities talk about, why do people care about a place where there is no people? And it was a striking experience as a graduate student where I was basically, you know, a helper. It wasn't my project, it was my PI's project, but it has left an indelible mark on the nature of how we do protection and the need to try and think about it as an integrated system where we're not going to reach sustainable goals if we don't try and understand the social structures that support inequity and serve to perpetuate it. So inequality, right? Let's start talking about that. Environmental inequality, I define it as it's defined, I don't think this is me. I think this is a combination of a few authors that I really follow closely. Environmental inequality, inequities in the distribution of environmental privileges and problems across social groups. So I think we're really familiar with the problems part of this statement, right? So we talk about issues of environmental justice. We talk about communities that face contamination and the hallmarks of what you might expect and the patterns across landscapes for those types of problems, right? We talk about that a lot. And I think most of the time when I mention environmental inequality, people think environmental justice right away. And I will try and conceive of this topic as quite a bit broader than that, to include not only inequity in problem, but also inequity in privilege. And that these two things are inexorably linked. And to understand why we have a perpetuation of environmental problems, we need to do research projects that link it to inequities in environmental privilege. So what are environmental privileges? Well, you know, there are projects out there that look at these types of things. So researchers have shown that some societies pollute more significantly than others, and I would categorize that as a privilege to do this types of pollution, to live in a way where you are able to do this type of transfer of bads or something like that. Some groups within society consume far more resources than others. Some industrial firms contribute much more environmental harm than others. And I've mentioned like my favorite papers here, right? But like this is a large body of literature. Although it's not super cohesive, it's not called like if you go into Google Scholar and you type in inequity and environmental privileges, you kind of have to wade through it a little bit to see it. But everything from, you know, how we see historical, you know, emissions levels to, you know, firm by firm footprint calculations, right? Some are worse than others, right? And that is like not an earth-shattering thing, right? Most people can, you know, look at the different climate scenarios or meaningfully think, yes, sure, some industrial firms are worse than others. But I would challenge you to really think about like how much worse, right? Like, is this like a really extreme distribution, or is this just something where some are moderately different than others, and we would still expect a normal distribution or something like that? So that's a foreshadow a little bit, because these distributions are quite extreme, and I'm going to do I'll show you a project I did recently to describe them. But what does this research typically look like? I'm in the habit of showing empty graphs here so that I can orient you to what I'm going to show you before I populate the graph, right? Because otherwise, if you're like me, someone shows a graph and I just immediately try to interpret it. So what am I going to show you? So often when people are doing this type of work, they're plotting Lorenz curves, which are used to describe valued resources across different economies typically. And what it does is it plots the contribution of individual polluters on the x-axis and the cumulative proportion that they represent of the hazard or of the wealth or of the valued resource in general on the y-axis. If it's a totally proportionate relationship, right, as you, if you march out, you know, one actor, you go up 1% of the total wealth or the total hazard, right? If you have two, you know, 20% of the actors, you also have like 20% of the cumulative, whatever value research you're looking at. In our case, I'm looking at hazards. So if you have a Lorenz curve that looks like a diagonal line, then you are, you know, looking at a really equal society or, you know, group of actors or something like that. Just to give you a little context, usually Lorenz curves are described using a Gini coefficient that ranges from 0 to 1, 0 being perfectly on this diagonal line, 1 being, you know, hugging the x-axis and then jumping up way at the end. For a bit of context, economies like apartheid South Africa had Gini coefficients of like 0.7 or something like that. So that's a pretty high Gini coefficient in the scheme of incomes. It matters what you're looking at. So we wouldn't necessarily expect pollution to, you know, follow the 0.7 rule, but you know, it's a good benchmark. So I've done a lot of different projects over the years where I've plotted pollution in this type of way. And if you look, this is you know, this is hazards that are these are industrial hazards in the US. You can see it's very disproportionately distributed. The Gini coefficient is 0.96. This is from my dissertation. And often when you talk about these types of things, I get questions like, well, what if like all of the actors that are out here or all of the firms that are out here are actually like all in the same industry or all doing the same industrial process or all doing one type of, using one type of chemical, or maybe they're all in one part of the country, or maybe they're all, you know, doing something really good for the world, like doing, you know, have really carry a lot of employees or something like that. So I've done a bunch of projects that try and explain or try and control for this pattern. And one of them is to consider things like employment, right? So if you normalize emissions per employee, so instead of you look at say we're looking at emissions in pounds, which we aren't in this case, but that's an easy way to think about it. And you go, instead of looking at pounds, you look at pounds per employee, right? And you give facilities like kind of societal credit for doing, you know, job creation. What you see is it's as expected, this line does move towards the diagonal line of equality, but not substantially. And so what you should be thinking is that, you know, we hear in the world, right, when you look out of the like the academy, for example, like we hear a lot of times talking about pitting economic development, job creation against environmental controls. And that is you know, normative rhetorical tactic that goes on, and we hear about it, and it's not true. Like, it is expensive to employ environmental controls, but when it comes to employment, you know, we don't see a huge shift. That's not going to completely control this scenario. So there's quite a lot of disproportionality research out there. It really focuses on thinking about pollution production or environmental privilege as a key aspect of society's relationship with nature. And there are like quite a lot of striking findings, right? Some industrial sectors, for example, like in the primary metals industry, vastly disproportionate, right? Like 1 or 2 facilities in that industry accounts for like 80 or 90% of toxicity within an entire year's worth of data. We've also looked in a variety of other industries, including the chemical industry, the electric utility industry, and they're all like, you know, they're the devil's in the details, right? But a lot of these patterns are very stable. You can also go up to the sectoral level, and we do find that there are some sectors that are worse than others, but these numbers, the Gini coefficients do drop significantly. So that's a little confusing, right? You see more inequality within group than you do between group. And so what does that mean for how we think about pollution production, and why do we see these patterns perpetuated? So what I've been doing for the past, bunch of years here is I have this big long list, right? And I'm summarizing it here for you, but in my old office, I had a big whiteboard, and I would like write down any idea I had about why this pattern might exist, right? So you can imagine, well, maybe it's their environmental context because, they're, incredibly close to some sort of vulnerable landscape setting. Maybe it's their social context, like, they are, employing an entire town, and so they should be allowed to release this much, hazardous material. Or maybe they're doing some other sort of, prevailing good. Maybe there's an endogenous facility characteristic, like what they do, what they produce, how they do it, how they employ controls. Maybe it's an exogenous facility characteristic, like regulatory surveillance or compliance histories, these types of things. This is like an exhaustive list of what I've been interested in over the past several years, and some of the projects I have started to work on, and some of them are, resting in the back, ready to be, to come out at some point. But the one that I was most interested in earlier in my career was maybe these extreme polluters are located in places that we think of as having also extreme environmental problems, right? So linking the production of environmental hazards to like the receiver of environmental hazards. And there's a huge body of environmental justice literature that's documenting in, very painful detail, the experience of environmental justice communities. So what we did was, this is a paper that I wrote with two computer science colleagues. And what we did was we looked across, release by release, polluter by polluter over 1 year. We did a lot of different controls, and what we found was that not only could you identify a class of what we were calling hyperpolluters, but those hyperpolluters exist almost exclusively in what I would consider environmental justice communities. This is an advance in the way that, in the computational approach to environmental justice, and also was highlighted the need to both think about the group that is sort of dealing with the outcome of hazardous activity, but also the societal and economic organization that produces the hazard, right? Explicitly linking these things together. So I have spent, that's sort of like the, beginning of my career, right? And like when you are in the beginning, right, you're spending a lot of time looking at the work you need to do, right, to achieve and move toward, participation within the academic environment. But when you look out, you can try and get some sort of reinforcement as to like, okay, we have all these academic works that contend that, this is a key feature of how society's impact on the environment might look. But what if you look outward? Like, do you also see this, right? So it's also really easy to see this when you look into the, popular media, or the, kind of, Science Times style media. So this is from early in 2022. Headline: just 5 major polluters could cause extreme climate impacts. This is from The Guardian. Earlier, March 2023, 1,000 super emitting methane leaks triggering climate tipping points. And even most recently, we see huge air pollution issues in Delhi, where you have kids not going to school, the contention that masks are not enough. And this is an evolving situation, so I don't have, a specific number of what is going on here, but if you are to take what we know to be true you know, at the edge of pollution production or inequality and environmental privilege, and then try and think about, okay, like how would we tackle this, or how would we understand the socio-environmental system that is supporting this type of reality? You know, what would we expect to do? How do we generate science that answers these types of questions or tries to contribute to solutions? Okay, so knowing what we know from science, how do we link science to solutions? Well, first of all, I would challenge a simplistic view about a trade-off between economic productivity and environmental quality. There is a trade-off, right? But let's spend a little bit of time complicating that and not looking at it as a simply one-to-one trade-off. All of the disproportionality literature in the popular press, in the academic literature, says target the worst hazards. Don't look at hazards as all exactly the same. Figure out which ones are, you know, the worst and target those. And a lot of the, you know, environmental justice work that I have worked on, as well as the colleagues that I've worked on, that I've worked with, have talked about how not only would you be changing the pollution footprint in whatever industry you're working on, but you're likely going to be working in environmental justice communities if you tackle the worst of the worst. And lastly, and this is just sort of a side note, try and think outside of a normal distribution where means are good estimators, right? If you are living in a world, like, it's really hard, right, to not think that a mean is a good estimator of what you're looking at, right? Oh, it's just average. But if you're looking at a hugely disproportionately or log normally or exponentially distributed distribution, a mean is going to send you down the wrong path of understanding what this is, right? You're going to end up totally underestimating the worst of the worst, and, you know, basically overestimating the vast majority of the actors within the distribution in my case, right? And that's a good reminder. And honestly, it's been, you know, almost 2 decades of me thinking about this stuff, and I still can't really think in log normal space, right? My brain isn't quite there. All right, so this is my first little example. All right, so we all, you know, we're here in 2020, and this is a good example because we see paper, you know, you see popular press articles like this: COVID-19 lockdowns have strange effects on air pollution across the globe. First of all, like, is it really strange? I don't know, but it certainly is striking to see things you haven't seen before, right? But inherently, like, you know, you're seeing mountains you haven't seen before. You're seeing, you know, the world is feeling different because of the change in societal habits, right? But the way that this is talked about at this time is basically saying that, like, oh, we need to, like, the COVID-19, while it's been bad for the world, like, in balance, right? It's been good in certain scenarios because the shutdown of economic activity has vastly changed pollution profiles in communities. And as a person who is trying to not think like a normal distribution, I read this and I think, like, but do we really need to just shut down the entire world? What if we thought more strategically about pollution reduction and did a policy simulation, you know, idea where we, like, really take into account the nature of pollution production? Okay, so I decided this was a benefit of not being a field work person. You know, I'm a modeler. So when COVID-19 happened and the universities were shut down, I still had my computer. I was still working. And so I decided with some friends of mine, close colleagues, that we would do some thought experiments and simulations. So, like, what if we shut down industries or shut down facilities, or tried some various pollution control ideas that were you know, meaningful in the context of non-normal pollution production. All right, so we simulated a bunch of management scenarios. What if we did industry level shutdowns, and compared that to business as usual scenarios, facility level shutdowns, and then some benchmark facilities performance standards. And I will explain that in detail in a second. So I had a bunch of data sources. I used the National Establishment Time Series database, which is a proprietary database that tells you a lot about the management strategies at individual establishments. And those individual establishments are also included in the US EPA's hazardous release data. So data source 1, toxic release inventory and the risk screening environmental indicators. These data sources catalog the hazardous waste generation of about 50,000 facilities. I had more years than 89 to 2012, but I needed to link the data together, so I made some decisions in that way. And then I also had information about what was going on at these different facilities related to from the National Establishment Time Series database. So what I did was I merged these two databases, and I was able to get both the number of employees that those facilities had on their payroll every single year, as well as the annual release from hazardous waste per the permit that they had. And I knew something about their place within the economy, so the sector in which they worked. Overall, there was about 26,000 facilities included in this analysis, spanning the continental US. There were almost 400 sectors represented in the analysis, and I ran it from 1988 to 2012. So this is a facility by facility analysis where every single facility has a total hazard number, as well as a total number of employees. And really what I want to do is I'm going to, I'm not engaging in how to design a policy that might do these things, but I'm trying to game out, like, if we, various scenarios based on a hypothetical policy scenario. So back to a graph with nothing on it, so that you can be prepared to see these things. I'm going to show both loads of employment and reductions in hazard as a proportion of the business as usual scenario, which is no change, over time. I decided to do this over time because I didn't see any papers really that talked about this sort of temporal stability of this pattern, so that's why I decided to do it. So I'm going to simulate basically the total shutdown of industries, which no one would ever advocate for, but since this is a thought experiment, I thought I would demonstrate it. The total shutdown of facilities in percentages, and then a policy simulation where what I'm simulating is the worst of the worst within each sector to simply decrease their hazardous footprint down to the worst excluding them, right? So if there's 100 facilities and I'm going to decrease by 10%, I'm going to just say those worst 10% have to be just as bad as those that are the worst, excluding them within their industry, right? So those are that's my and these are, they're somewhat crude, but so, what do we find? So the first one I did was a random industry shutdown, and you can see if you shut down 25% of an industry, you lose about 25% of employees. And because if I shut down this industry, then everyone gets fired. And if you and you also lose about 25% of hazard, right? Instead, if you bounce around a median and you shut down 25% of industries, bounce like 12.5 above the median, 12.5 below the median, we see something a little bit different. So you have a pretty substantial decrease in employment, right? 25%. We're down to 75% as business as usual, and almost no impact on hazard, right? That's because hazard doesn't live around the median, right? Hazard lives way out in the tail. So instead, you do a targeted 25% shutdown of industries. what happens is you do lose a lot of employees, right? So I'm shutting down 25% of industries across all these years. It's about 84 industries of the 400, which is a lot of industries, right? But we lose a ton of hazard too. We like business as usual hazard comparisons go way down. And you can kind of see it, you know, this pattern continues as you shut down the worst 10% and shut down the worst 1%, where we see, you know, huge changes in hazard and, you know, what you might expect in terms of employment. And lastly, I'll just point out that like these patterns are pretty stable. This dip is a little hard for me to explain, but overall, you know, I've convinced myself this isn't like an artifact of 1 year, right? There's sort of more going on here. So as I mentioned, no one would ever say like you should shut down whole industries. So instead, I decided that we would do this at the level of facility, right? So what we're doing here is, again, the same scenarios, shut down 25% of facilities, you lose about 25% of hazard, and you lose about 25% of employees, right? This is you know, not super surprising. This one, right, is clearly like the worst thing you could do, right? You're bouncing around a median, you're gonna lose like 25% of employees and get like no hazard. And again, like if you really think about like the generation of or the sort of non-normal generation of pollution production, how that density function would look, all of the density is located like way far out on the x-axis. So when you bounce around the median, you get none of the hazard, right? But we start to get some traction, maybe, in a facility-based scenario where you shut down the worst 25% of facilities. In that case, when you shut down the worst 25% of facilities, it's about like 3,300 of 40,000 facilities that you're shutting down. It's still probably not palatable for policy decision makers, but it's not a huge number of facilities compared to the number included. And in that case, your hazard goes down to almost zero. This is not quite zero, but it's very close. And you do lose a lot of employees. That's probably too many to lose. And you know, these patterns are also the same when you shut down about, you know, the worst 10% or shut down, you know, the worst 1%. You're not, you know, you're not impacting employment that much, and you are making a big dip in hazard generation. So what about the performance targets? So again, this is just like a real baby step towards a real world scenario, right? Because like none of this is all thought experiment, but imagine you avoid a shutdown, right? So in this case, we lose no employees because no industry shut down, no facility is shut down. So you can see my employment is going to stay the same as business as usual up here in every case. But instead, what I'm going to do is I'm going to compel via some creative and effective policy instrument the worst of the worst to just be less worse than they are, right? They just have to be as bad as the worst actor in their industry, excluding themselves, right? And what you can see here is that like we lose no employment, and if you shut down or if you target and compel them to go down to the max within their industry, we still see really substantial changes in pollution footprints. Again, it's important to remember that most of the literature that looks at looks at pollution generation in this type of granular way, when you link it to communities, like a lot of these worst actors, if not you know, the vast majority, a lot's probably even underestimating, are located in places where there are problems on the landscape like community contamination and environmental justice signals. Okay, so we ended this paper by you know, trying to compare all of these different scenarios to one another and put them on like a trade-off frontier, right? So where you want to live is way up here, where you're maintaining a high proportion of business as usual employment, and you're also I call this hazard reduction just to make the graph look better because I wanted to live up here instead of down here. So this is where your high proportion of hazard reduction, which is a little different than the ones I was showing you, and a high proportion of maintained employment. And so the two scenarios that do best are the performance targeted 25%. So that's compelling the worst 25% to change their footprints just to the worst of the group in their industry that is not them. And the facility targeted 10%, which is probably a hard policy case to make. So what did we learn from this? Well, two simulations stand out as most effective, and I already mentioned those. Honestly, like, I've been looking at this for a long time, and I was surprised at how terrible the median-centered ones were. I mean, it makes complete sense after it's like after you look at it, but the non-normal nature of pollution production in the industrial sectors in the U.S. is like striking. And so the median, does the worst because it doesn't capture anything in the context of hazard reduction. Random shutdowns really do show this direct trade-off that's often talked about in the popular press and sort of narratively in the context of environmental controls. And but really, like, this is just a fun thought experiment that I did when the world was shut down. So the next step is really doing formal modeling to try and understand predictors of extremes, and with the colleagues that I've been working with, which are Simone, Dustin, and Ben, we've been trying to think about how to get more information so that big long list of reasons why these patterns might exist could be operationalized in a formal modeling setting. I think that one of the reasons why I wanted to share this with you is that it was a really fun project for me, and I think that a lot came together for how my history and my current interests I was really able to pull things together in a way that was that surprised me and was very interesting to me, right? So in some ways that is a way for me to convey the fact that I'm interested in what I would call data synthesis, pulling together data sources that aren't necessarily supposed to be linked together, but you can link them together. I also think that modeling is one way that I have generated and maintain and continue to be part of the most fascinating and exciting and complicated interdisciplinary collaborative efforts that I ever imagined in my career. And so, while this paper is really, really at the heart of, I think, what I'm interested in, a lot of what I end up doing is collaboration via a modeling project, right? And so the next two projects that I want to talk about, which will be much quicker, are really in that type of vein. So, what does it look like to collaborate with me? So one of the most amazing collaborations I have had in the last, ever, I would say, is the New York Wastewater Surveillance Network. So this is a multidisciplinary collaboration that tracks SARS-CoV-2 in the wastewater, started in March 2020. And really, it was a bunch of academics whose kids were not in school, and we were interested in understanding more about what the risk was. At that time, I was up in upstate New York at SUNY ESF, and New York's response to the pandemic was so influenced by New York City, right? And as a person, way up in Syracuse, I wanted to know, really it came from a place of wanting to know, can I go to the playground with my child, right? How much risk is there, right? And the way it was being talked about was hard to suss that out, right? For everyone, I'm sure. But so we decided to public health molecular biology in some ways, definitely microbiome. I had some close colleagues in that department, and 2 chemists. And really, we came together to try and establish an early detection of COVID-19 within communities, capturing data from both systematic and asymptomatic individuals, because everyone is going to contribute to the wastewater. We partnered with some of the molecular analysis core professional people and amazing experts at Upstate University. And what we did was we set up an early warning system for COVID-19. We ended up connecting with Department of Health, and it was really a sort of scrappy group that is now quite large. The last meeting I went to was a few months ago, and I think there were 80 people in the room. When we first started, we were all, we could all, fit in a small space. So what was really my role in this? I'm not doing PCR, right? I'm not a microbiologist. My role is really data visualization, and I'm a member of the modeling team. So the first thing that we ended up doing was we created a dashboard. This dashboard is live. It's hosted on a Shiny site that I host, and I pulled this last night. This is this is just a way to try and communicate what's going on across the state. So it's live right now. I can give you the link afterwards. And this is a large collaboration really between all of the members of the team, because we have an entire sort of data throughput strategy where, we have sampling going on at wastewater treatment facilities across the state. And then we have private labs and institutional labs that are doing the PCR and reporting back to the system. We have data management through, Amazon Web Services. We have a Shiny app that is on a public GitHub repo, and it started as a sort of weekend project sprint with a postdoc that I work with, and now it's it's not an everyday thing the way it was at some point, but it became a lot more than I thought it would become. And so we decided to write a paper about how do you operationalize open source dashboards for communicating environmental surveillance results. And that came out pretty recently. So I'm interested in, how to do visualization. We have so much potential with this project from the standpoint of trying to understand what is exposure to these mapping risks? How does it change your behavior? We've done none of that work. We've spent a lot of time trying to get it up and running. Rather than moving towards doing some of these analysis projects that we want to. One of the analysis projects that we did really recently is we were interested in using wastewater to forecast system stress, and system stress in this case is hospitalization. If you remember early in the pandemic, hospital stress, the allocation of ventilators, other types of resources. How do we forecast this to the system, the healthcare system in this case, so that preparedness and response can be supported by these types of data collection activities? So in this case, what we did was we used spatially explicit data at various spatial levels from sewershed, county, and at the state level. And we used general linear modeling framework to predict hospitalizations from RNA levels. And we used a 10-day lead time here for a variety of public health and important reasons, but we analyzed weekly wastewater alongside vaccination rates, demographics to forecast these types of spikes. What we found was that including wastewater information really helped the predictability of this model. And we were really able to do a pretty good job in hindsight. There's more work to be done for sure, but I'll show you one figure from this paper. So we have a significant correlation between the delayed impact of an RNA rise and then a hospitalization of about 10 days. So it's a little hard to see this here. Our observations are in red, solid red line. And then we have a bunch of models, right, about how you might try and predict this hospitalization rate. The first is using case counts, which works really well. in some settings, but not in surge settings, right? So this is a surge in hospitalizations. This is the Delta wave. And these are the two other surges early in 2022. And you can see that they don't perform that well right here. We have a test positivity one, and we also have these last two, the solid blue line, and then the dotted line is wastewater only. And we are able to have better predictive ability by including wastewater in these models. And again, this was a really collaborative experience, and it was notable. I would say that the wastewater data improved our ability to forecast hospitalizations out about 10 days. The modeling effort has been it performs well in data, but we do have some concerns about sort of how applicable this model would be to new pathogens or new diseases or new scenarios. But it's been a really exciting new start. So the last two slides that I have today are sort of about, so what does this all mean? Where am I going? How do these things all link together? So I'm really interested in how do you take what we see to be true in research ventures and make sure that it's relevant to what's going on in the practical world, right? So translational environmental health involves taking scientific findings, applying them to practical solutions, policies, and interventions that protect and improve public health. A lot of what has been going on in this arena is thinking about, science existing as a collaboration between those who might use the science and an endpoint. So we talk about like co-creation of hypotheses and community involvement broadly, or stakeholder involvement throughout the process. So, in this realm, what have I been doing lately? Well, I have been pursuing innovative grants with some of you in this room. Namely, we've submitted grants to NIH about setting up a Superfund research center, looking at 1,4-dioxane in wastewater, and thinking about issues of extreme climate and mental health that could be co-located in the event of those things. Those are with the Program of Public Health. Jamie Melliker's leading them, Sharon, Christine Gilbert, and Anna Hayward from the School of Social Work. We've been working together to try and get those things submitted. I'm very interested in getting involved with community leaders and trying to understand more about what they need, so that the science that I do is connected to what the needs are on the ground. I continue to feel like sustainable achievement is not only related to health equity, but is dependent upon it. And so continuing to operationalize environmental inequality in all that I do is certainly going to be going on. I'm interested in future collaborations. I was very inspired by the Long Island Sound Study work that I got to hear about the last few weeks of this seminar. And I think that there are real synergies between some of the population dynamics and exposure metrics that I saw in those presentations. I think that it's critical to empower local decision making, and that really working alongside policymakers is going to maximize the possibility of translation. And again, really am committed to those types of things. So I bounced around a lot, right? I had 3 papers that are not quite like one another that I want to demonstrate all that I'm been recently working on. The citations for these 3 papers are below. And the hospitalization paper is like hot off the press. I think I saw the final release on Tuesday. So it's been a really, really amazing experience to come to Stony Brook. In a lot of ways, it's like coming back to what my life was like in graduate school, where everyone with all these different skills are all in the same room. The problems of that and the exciting aspects of that are real here, and I've been extremely excited to be here, and hopefully we'll get to work with a lot of you in the future. Happy to. Yep.
Interesting talk. Questions related to the polluter shutdown.
Sure.
So does your data, so the two things that jumped out at me that also need to be considered is the number of widgets that those factories are making and the cost per widget.
Right.
Does your database include that type of information so you could actually look at, because like you shut down 25% of the factories, the other factories are going to make more, or new factories are going to start up, right? So
yeah, that's a good question. So I don't have necessarily like production activity, I would call that, right, for every single facility. But in some cases so a reviewer pointed this out, in some cases, number of employees correlates with that. So while it's imperfect, it is a correlated metric, but it really matters what industry you're working in. So for example, like electric power generation, if you look at megawatts generated or something normalized in a way to normalize the hazardous waste footprint, a lot of these things decrease dramatically. So especially in that industry, the larger the productive footprint, it really matters. But we see sort of the opposite in things like petrochemical sectoral work. But no, we don't have data that are right up to my fingertips on that. But that's a really important point. And normalizing by some size metric is important, right? And employees was one effort to do that, but it's not perfect.
So we have a question from Chet.
It's real. I'm in Panera.
Okay, wait, we can't hear you.
Can you hear me now?
I don't know how to turn it up. Oh, wait, we can hear him. There you go.
Okay.
See, I'm in a really loud place. I typed my question into the chat.
No, we can't hear you.
He's gonna type it. He said he's gonna type it in the chat.
Okay.
Oh, okay.
Wow, how did you hear that?
Yeah, it's coming out of this speaker really quickly.
Here you go.
That. There you go. Okay. So, thank you.
How do relationships between proportion of releases and proportion of hazards, impacts, and effective amount of change as the impacted groups are non-human species or specific ecosystems? Well, I don't think I have a really great answer for that, except to point towards like, so there are some colleagues that I have in limnology at Wisconsin, and they sort of talk about how the effect or the extreme effect is really about the vulnerabilities on the landscape rather than vulnerabilities in the social system. And I find one of the people, I do have the citation in the talk, and I find that it's probably both and neither and one or the other, depending on the situation that you're in. But I think that the heart of your question from my perspective is a better operationalization of the biophysical vulnerabilities in these scenarios. I'm a social scientist, right? So I tend to lean towards some of the social science databases with more savviness. But collaborators who could operationalize landscape vulnerability more effectively would be a huge benefit to this work.
Okay, thanks.
Oh, we can hear you.
Yeah.
Thanks, Jay.
Thank you. Kamazima.
Yeah, going back, stay back at the shutdown scenario.
Okay.
What caused the dip?
Oh, yeah. I shouldn't have pointed out that I didn't know how to answer that, right?
Yeah.
So, so these, the hazard data, right? So this is just a hypothesis because I didn't test this, right? But, the hazard data are generated after, there are rules, right? Associated with who's submitting hazard data to the toxic release inventory, right? It's not like, there are monitors at every site across the world, a country, right? You have like industrial managers that are filling out Form R reports, submitting them to EPA. And whether you have to submit and what you have to submit changes over time, right? So part of the reason why I picked 1998 to 2012 is because the reporting requirements are sort of as constant as you can hope they will be, and they're not constant. So my hypothesis is that the industries that are in this 1% are, there was a reporting change in 2008. And I feel like if I did that would be my hypothesis, that all the industries that are somehow like more subject to that rule change than some of the other ones. Yeah.
This is just, yeah, so is the dip's 2007, right?
Yeah.
Isn't that like the world financial collapse?
Oh yeah, maybe.
Yeah.
Yeah, that's a good
Why
one
did
too. Yeah, maybe. In 2007, I think I had no money to collapse.
Yeah, I was a postdoc, so I was just thinking about having money to collect.
Yeah. So, but yeah, no, that's a good, yeah, I mean, I think that both of these questions and hypotheses are like, highlighting of the fact that, you know, we can't ever include everything in a model, you know, and there's, you know, a lot we don't know and can't include, you know, or ends up in like, you know, the random effects or something.
So did you get like the EPA or somebody come to you and did they say, hey, which ones? What should we do? Or was it, like, how was this received?
Yeah,
Study?
that's a good question. So I have a long-standing collaborative, although you know, don't publish papers with them, but the Office of Pollution Prevention and Toxics, OPPT at EPA is like filled with people who like are so heroic they should like wear capes. You know, there's like 5 of them doing all the work of the entire world or the entire country. And I know that people get really frustrated with EPA and like sometimes, but my experience is that when you reach out to EPA, they're more than happy to talk to you. And I've had great luck and great advice from them over the years. And so every time I use TRI or risk screening environmental indicators data, which is like the cousin of TRI, I always give them a heads up for a few reasons. One is that I want to know what they think. And the second is that I want them to be able to defend this data, right? All of these data are congressionally allocated via budgets every single year. They defend them vigorously, right? Especially in the years 2016 and 2020. And it's really important in my mind to be actively connected and have relationships with these people. So honestly, when I talk to my EPA colleagues, they are both, you know, not surprised in some ways, but they're also, you know, excited to sort of know about it. And I think that like, while, you know, these are bird's eye views, these are aggregate groups, like it doesn't really tell you about any one facility, right? And like, if your community is dealing with a facility, that's the most important facility. It doesn't really matter where on the line it's located, right? So EPA people, in my experience, are balancing things that I'm not balancing always. But I've had extremely positive experiences talking with the enforcement groups, and you know, I did a fellowship in 2009 in Region 5, where we tried to use algorithms only to do facility inspection targeting, and It was, it's an amazing group of people.
Do we have any student questions?
Thank you so much.
Thank you.